Good morning. Today's topic is advantages of electrical transducers and factors to be considered while selecting a transducer and capacitive transducers. Right? In a in yesterday's class, we have seen the classification of transducers. Okay, the classification of transducers. So generally, transducers are classified as on the principle on the basis of transduction means primarily primarily the principle which I am using to convert one form of energy to another form of energy, it is the first basis. Okay, it is the first basis based upon principle of transduction. And second classification is primary and secondary transducers. Third classification, active and passive transducers. Fourth classification, transducers and inverse transducers. Fifth classification, analog and digital transducers. Right? So analog transducer means a transducer which accepts analog signal as input and produce analog output. Means it produces output in a continuous time domain. So if the transducer provides me output in a continuous time domain, then it is called analog transducer. And if the transducer gives me output in digital form, then it is called digital transducer, means in a form of pulses. For example, I want to measure speed of a rotor, right? And I'm using a toothed rotor type instrument to measure speed. So it will provide me pulses. So the frequency of pulses gives me the speed of rotor, okay, or speed of a shaft. So it is a digital transducer. It use output in a form of pulses, ones and zeros. Okay, and a transducer means a sensor or an element or a device which converts non-electrical form of energy into electrical form of energy is called a transducer. And inverse transducer means an element or a device which converts electrical form of energy into non-electrical form of energy. It is called inverse transducer. So active and passive transducers. Active transducer is an element or a device or a transducer which doesn't need any external power supply for its working. So I don't need any external power supply for the working of a transducer. Then it is called an active transducer. On the contrast, the passive transducer means a transducer which needs external power supply for its working. That is called passive type transducer. Right? Next classification, primary and secondary transducers. Primary and secondary transducers. So a primary transducer is a transducer which takes, which accepts the input. Means in instrumentation, if I want to measure any physical parameter or industrial parameter like pressure, force, humidity, moisture, speed, velocity, acceleration, temperature, pH, conductivity, flow rate, etc., etc., etc. So if I want to measure any physical parameter, I want to convert it into electrical signal. I want it means if I have voltage or current or frequency, I want to convert them. So each and every time a single instrument doesn't gives me electrical output. So I have to use a series of transducers. A series of transducers. So for example, I am using here two transducers. I am using here two transducers. Okay, two transducers. This is transducer 1. This is transducer 1, and this is transducer 2. Okay, so I need two transducers to convert input into electrical form. This is input, and this is output. So output is in output is in electrical form now, means voltage or current, voltage or current. So I need, sometimes I need a series of transducers, 2, 3, 4, 5, so on, so on, so on, based upon my requirement. So this is first transducer, this is second transducer. This is called primary transducer and this is called secondary transducer. Means the primary transducer accepts the input and converts it into some other output, right? Some other output, right? So second transducer will take output of first transducer and converts it into final output, which is my electrical signal. Okay, so in this case, this transducer, in this case, this transducer, I call it primary transducer, and this is called secondary transducer. For example, for example, for example, here I am using three transducers: transducer one, transducer two, transducer three. Okay, I'm using here three transducers, and the output of first transducer is fed as input for second transducer, and the output of second transducer is fed as input for third transducer. Okay, this is first transducer, right? And this is second transducer. This is this is second transducer, and this is third transducer. Okay, so here I am giving input. Here I am giving input, and this is my final output, which is my electrical signal, right? Which is my final output. So in this case again, this is called primary transducer because it is taking the input and giving some output and giving some output. Auxiliary output I call it. I call it auxiliary output. Auxiliary output 1 I'm calling it, and this second transducer will takes the output of first transducer, which is auxiliary output, and it is giving some other output. So output 2 I am getting here. This is also an auxiliary output, and this third transducer is taking the output of second transducer and is giving me my final output, which is required electrical signal, which is required electrical signal I am getting here. This is the final output. So voltage or current I am getting here. In voltage or current form I am getting here, for example, right? So in this case also, this transducer, in this case also, in this case also, this transducer, I call it primary transducer, and these two are called secondary transducers. Okay, these two are called secondary transducers. So this is primary, and these are my secondary transducers. Okay, and the last classification, of course, first in our list, it is on the basis of transduction. Okay, so transducers based upon principle of transduction, means which principle they are using to convert the input into electrical output. So based upon that classification, I am classifying the instruments or transducers. So I may classify the instruments based upon, for example, if the instrument is using a resistive principle, if the instrument is using resistive principle to convert input into electrical form, then it's called resistive transducer. And if the sensor or transducer is using change in capacitance, to convert one form into to convert input into electrical output, that is called capacitor transduction. And for example, if the instrument uses inductive principle to convert input into electrical form, that is called inductive transduction. And for example, if the instrument uses piezo resistive principle, piezo resistive principle piezoresistive principle to convert input into electrical output, then it is called piezoresistive transducer. And then if the instrument uses piezoelectric, piezo, P-I-E-Z-O, right? Piezoelectric principle, piezoelectric principle to convert input into some electrical output, it is called piezoelectric transducer. And if the instrument uses photovoltaic principle, if the instrument uses photovoltaic principle, photovoltaic to convert input into electrical form, it is called photovoltaic transducers. So likewise, the first classification is based on, right? So it is based on the principle of transduction. It is based on principle of transduction. If the transducer uses resistive principle to convert input into electrical form, it is called resistive transducer. And if the instrument uses capacitive principle, changing capacitance to convert input into electrical form, it is called capacitive transducer. And if the instrument uses inductive principle to convert input into some other form, that is called inductive transducer. If the instrument uses piezoresistive principle to convert input into some other form, then it is called piezoresistive transducer. And if the instrument uses piezo resistive principle to convert into some other form, that is called piezoresistive principle, piezoresistive transducer. And if the instrument uses piezoelectric principle to convert input into some other form, that is called piezoelectric transducer. And if the instrument uses photovoltaic principle to convert input into some other form, that is called photovoltaic principle or photovoltaic transducer. Okay, photovoltaic transducer. Likewise, the classification is based on. So in this unit, we will study all this classification. Okay, we'll study every topic based upon this classification. Okay, so in order to move further, let us talk about advantages of electrical transducers and on which basis I have to choose particular transducer for a particular measurement. Okay, then we will go in deep on the classification of transducers, right? So advantages of electric transducers. Primarily, primarily the instruments are classified as three types: electrical instruments, electronic instruments, and mechanical instruments. Okay, electrical instruments, electronic instruments, and mechanical instruments. Similarly, the transducers are classified as electronic transducers, electrical transducers, and mechanical transducers. So nowadays we are mostly using electrical and electronic transducers only, and we are limiting the usage of mechanical transducers. Okay, and if there is certain, if there is, if for a particular application, I for a particular application, I want to use a mechanical transducer, then I will use it for definitely. So I am limiting the usage of mechanical transducer much more. Why? Because generally in industries, ఎలక్ట్రికల్ ఎలక్ట్రానిక్ ఇన్స్ట్రుమెంట్స్ ఎక్కువగా ఉపయోగిస్తాం, మెకానికల్ ఇన్స్ట్రుమెంట్స్ ఎక్కువ ఉపయోగించాం. ఎక్కడైతే మనకి మెకానికల్ ఇన్స్ట్రుమెంట్స్ మాత్రమే ఉపయోగించాలో అక్కడ మాత్రమే ఐ విల్ యూజ్ మెకానికల్ ఇన్స్ట్రుమెంట్స్. ఓకే, so if there is any particular application in which I want to use mechanical transducers, then I will use mechanical transducers only in that particular application. Okay, and maximum I will use electronic and electrical transducers only. Why? Because I have a lot of uh, disadvantages in using mechanical instruments. Okay, I have a lot of limitations also in using mechanical instruments. So, for example, mechanical instruments are much more rugged. It's advantage for me. Okay, mechanical instruments are much more rugged. They can have ability. They can able to withstand higher loads. They have ability to withstand loads, which is essential characteristic of any instrument. But even then, there are a lot of limitations for me to use mechanical transducers. Okay, for example, mechanical transducers are much more bulky, and and there are so many moving parts in mechanical transducers such that mass inertia problems arise. Okay, mass inertia problems will arise mostly when I am using mechanical instruments. And moreover, since there are so many moving parts are there in mechanical instruments, so the speed of response is very, very less. The speed of response is very, very less. Okay. And since there are so many moving parts, since there are so many moving parts, frictional losses are also occur in mechanical instruments, so that the output may not be accurate. The output may not be accurate, right? And since there are so many moving parts in mechanical instruments, the speed of response is very, very less. They, they create much more noise. They create, uh, they need much more space to install. And of course, installation of mechanical instruments is very, very easy than compared to electronic, and designing of mechanical instruments is very, very easy when compared to electronic and electrical instruments. Even then, there are so many disadvantages for mechanical instruments, like mass inertia problems, much more noisy, and I need periodic well maintenance, and I have to apply uh, some lubricants, okay, to decrease temperature effects and frictional effects. So all these problems that exist in using mechanical instruments. So for that reason, I'm moving on to electrical and electronic instruments. Electrical and electronic instruments. Okay. So so equally they can measure with with high accuracy. For example, I want to measure speed. Previously, previously, previously we were using flyball tachometer, fly, flyball tachometer to measure speed, which is not feasible and which is not accurate. But long past, these are the instruments which we generally use to measure speed. But now there are so many instruments: electrical tachometer, electronic tachometer, contactless type tachometer, means proximity tachometers, and so many electrical and electronic transducers came into existence nowadays. So, so if I use electrical and electronic instruments, mostly I can get high accuracy. I will get output with high accuracy. Okay. So mostly quantities to be measured are analytical in nature. So in industries, we will measure high temperatures, high pressures, okay, high flow rates, and I have to measure displacement, humidity, moisture, speed, velocity, acceleration, turbulence, and vibrations, pH, conductivity, so on, so on, so on. So I have to measure all these parameters which are non-electrical in nature. Okay. So these electrical instruments can measure all these parameters, right? And these parameters cannot be measured directly. For example, I want to measure temperature of a molten metal. Temperature of a molten metal. So it is not feasible for me to use an instrument in contact with the molten metal, in contact with the source of input. Okay. Why? Because if I put that mechanical if I put that instrument in the molten metal, then the instrument itself will melt. So there are there are so many instances for me, right, which they cannot be measured directly. Hence, such quantities are required to be sensed and changed into some other form for easy measurement. Okay. For in this example, what I am doing means, if this molten metal means it's very, very high temperature. Okay. So let us suppose the temperature may be in between the ranges of 1500 to 2500 degrees centigrade. So this much high temperatures I can't measure directly. So what I will do means, I will convert temperature into some other form which will be measured, such that the output is proportional to, or output is a measure of temperature. For example, let us suppose we want to measure temperature of a molten metal. or temperature of a lava, let us suppose. Okay, so in industries, let us take steel plant in which we will take iron ore and we will raise temperature to a high level such that the metal will melt. Why? Because the iron ore consists of a lot of impurities. So we have to purify it in order to use for our regular purpose, right? So we have to purify it. So if I raise the temperature, it will melt, and at a particular temperatures, all the impurities will be brought out and we will purify the metal. So we have to raise the temperature of a molten metal up to that extent. So constantly we have to measure the temperature. So I can't use any other thermometer or any RTD which will melt if I make contact with that input. So what I will do means every hot object emits radiation. That radiation falls under visible region, right? If the temperature is high, the radiation will be high. If the temperature is less, radiation will be less. So the radiation emitted by a body is proportional to hotness of the body, degree of hotness of the body. Degree of hotness means temperature of the body. So if I measure the amount of radiation it is radiating, then I can assess the temperature of a metal. So in this example, I am taking the radiation as a factor to measure temperature, right? So likewise, so likewise, so likewise, electrical quantities such as current, voltage, resistance, inductance, and capacitance, etc., can be conveniently measured, transferred, and stored. And therefore, for measurement of non-electrical quantities, they are to be converted into electrical quantities first and then measured. The function of converting non-electrical quantity into electrical quantity is accomplished by a device called electrical transducers. Electrical transducers means, for example, for example, I want to measure some parameter, and 99% in instrumentation, not 99%, 100% instrumentation, every time, every time, 100%. Okay, so every time we want to convert input parameter into electrical signal only, which is a voltage or current. Okay, so instrumentation, there is a range called 4 to 20 milliamp range. 4 to 20 milliamp range. So 4 milliamps corresponds to 0% input, and 8 milliamps corresponds to 25% input, and 12 milliamps corresponds to 50% of the input, and 16 milliamps corresponds to 70% of the input, and 20 milliamps corresponds to 100% of the input. So in instrumentation, we will convert every parameter into electrical signal, which is voltage or current, mostly in current. Okay, why? Because if I convert them into electrical signals, if they convert them into electrical signals, then I can measure them very accurate. Okay, if I want to amplify the signal, I can amplify. If I want to send this signal into some other long distance, then I can convert, then I can send the voltage and current signals easily without any drop. So I will convert every parameter into current signal only. Why? Because it is very easy to handle current other than voltage. Voltage may drop, but current doesn't drop. Okay, so voltage may drop, current drop avukunda నేను చూసుకోవచ్చు. There are uh, so many possibilities for me to maintain current easily without dropping rather than voltage. Okay, so what I will do is I will make a series connection. This is transmitter and this is receiver, which is far apart. Okay, so I will make a series connection such that current doesn't drop in series. Okay, so if I want to send my signals, I can send them without drop. So I will convert every parameter into current or voltage. If there is no possibility for me to convert it into current, then I will convert it into voltage, and then I will convert voltage into current again. Okay, with some uh, with some proportionality constant. Okay, so here, if I want to transfer, I can transfer electrical signals very easy, and I can store them. I can store the data. I can store the digital data, and it is very easy to measure conveniently. So these are all the advantages for me if I use electrical signals or electrical transducers or electronic transducers. Okay, and now and now basically, electrical transducers is a sensing device by which physical, mechanical, or optical quantity can be measured, is transformed directly with suitable mechanism into electrical signal. Okay, the production of these signals is based upon electrical effects which will be resistive, inductive, capacitive in nature, and we will see all these concepts in coming lectures. Right, in coming lectures. The input versus output energy relationship takes the different reproducible function. The output to input and output to time behavior is predictable to a known degree of accuracy, sensitivity, response within the specified environmental conditions. So, electrical transducers has number of advantages. Okay, so so all the physical parameters or industrial parameters like temperature, pressure, speed, velocity, acceleration, so on, can be effectively measured by so many electronic transducers, which follows resistive principle, inductive principle, capacitive principle, photoelectric principle, photovoltaic principle, magnetic principle, Hall effect principle. Okay, so on, right? So all the industrial parameters can be measured by these principles by using by using electrical transducers. So there are a lot of advantages for me if I use electrical transducers rather than mechanical transducers, right? And in some applications, and and the most important point to note is electronic transducers have much more advantages than electrical transducers. Okay, why? Because the only one drawback of electrical transducers is one thing, that is the output meters. If I use in electrical transducers, if I use output meter to show me the reading of the input to be measured, and the input to be measured is again mechanical instrument. Okay, the display instruments which I use for transducers or electrical instruments is again mechanical instrument. So, at the output, if I want to display something, something like pressure or liquid level, pressure or torque or temperature, again the output meters which I will use is mechanical instruments only. So all the problems associated with mechanical instruments will be also associated with output display devices. So for that purpose, in order to overcome that disadvantage also, I'm using electronic display devices for electrical transducers such that I can use with high accuracy, and I will get information with high reliable information I will get, and reproducibility will be increased, repeatability will be high, and accuracy is high, sensitivity is optimum, and it has high degree of resolution, and and there will be no hysteresis, which is the main point to consider. Okay, so all these are advantages I will get if I use electrical transducers. Okay, so what are the factors to be considered by selecting a transducer? Okay, so factors to be considered by selecting a transducer, right? So for a particular application, I have number of transducers. For example, if I want to measure temperature, then then I have a thermometer, I have an RTD, I have a thermocouple, I have optical pyrometer. So I have thermistor also. So, so if I want to measure a parameter, then I have multiple options to use. I have multiple options to use, multiple transducers to use. So I can select any transducer. So for a particular application, which transducer I have to use, and then select చేసుకోవాలి. Which transducer I have to select. It is the main point. Okay. So first one is range. Okay. For example, if I want to measure low temperature ranges, I go for thermistor. If I want to measure temperatures up to a range of 200 degrees centigrade, I go for thermometer. If I want to measure temperatures up to 700 degrees centigrade, I go for RTD. If I want to measure a temperature up to 1500 degrees centigrade or 2000 degrees centigrade, I go for thermocouple. If I want to measure temperature greater than 2000 degrees centigrade, I go for pyrometer. So range also is one of the major criteria to select a transducer. Okay, and second one is accuracy, degree of accuracy. Okay, which instrument gives me output with high degree of accuracy is the major concern which we have to look after while selecting a transportable transducer for a particular measurement. Okay, and third one is the instrument must have high repeatability and high reproducibility. High repeatability and high reproducibility. And the instrument should have high resolution. Means the smallest change in the input should also I have to measure. So the instrument with high resolution gives me accurate output. So it must be with high resolution. And the instrument must be highly rugged, means the instrument should have ability to withstand loads, and the instrument should have high input impedance and low output impedance to avoid the loading effect. And the instrument must be very small in size, and the instrument must be highly sensitive, optimally sensitive. Why? Because if the sensitivity is too high, then we have to compromise for stability. Okay, we have to compromise for stability. And if the sensitivity is very less, I will get errors in the output. So if the sensitivity is too high, then I will get then I have to compromise for stability. Why? Because stability will be decreased. And if the instrument is less sensitive, then I will get errors. So high sensitive and low sensitive, these two extremities I have to avoid this. So sensitivity ఎక్కువ ఉంటే కనుక స్టెబిలిటీ తగ్గిపోతుంది, సెన్సిటివిటీ తక్కువ ఉంటే కనుక ఎర్రర్స్ వస్తాయి. కాబట్టి I have to choose optimum sensitivity for the instrument. Okay, and the next point is environment in which I am using. Means some instruments will be corrosive if I use in oxygen environment. So environmental capability అనేది ఉండాలండి ఇన్స్ట్రుమెంట్స్ కి. అంటే ఫర్ ఎగ్జాంపుల్ if I want to measure uh, temperature of a steam okay, in a boiler which is not superheated steam. I want to measure temperature of a supersaturated steam. Okay, so ఏమవుతుంది if I use RTD or thermocouple which is made of copper leads, then అప్పుడు నాకు ఏమవుతుంది, ఈ కాపర్ లీడ్స్ అన్నవి కిలుం పట్టేస్తాయి ఆక్సిజన్ ఎన్విరాన్మెంట్ లో. అదే ఐరన్ ఉపయోగిస్తే కనుక తుప్పు పట్టేస్తాయి. సో ఇట్లాంటి ప్రాపర్టీస్ నాకు ఉండకూడదు, ఇట్లాంటి ప్రాబ్లమ్స్ నాకు ఉండకూడదు. ఓకే, సో ఎన్విరాన్మెంటల్ కాపబిలిటీ ఉండాలి ఇన్స్ట్రుమెంట్ కి. ఓకే, అండ్ ద ఇన్స్ట్రుమెంట్ షుడ్ బి able to withstand high pressure, high shocks, high vibrations, etc., etc., etc. So these are the characteristics which you have to look after while selecting a proper transducer for a particular measurement. So in contrast, in summary, నాకు ఏముండాలండి, హై ఇన్పుట్ ఇంపిడెన్స్ ఉండాలి, లో అవుట్పుట్ ఇంపిడెన్స్ ఉండాలి. దీనివల్ల లోడింగ్ ఎఫెక్ట్స్ నాకు రావు అండ్ రిజల్యూషన్ ఎక్కువ ఉండాలి. ఓకే, రేంజ్ ఎక్కువ ఉండాలి. ఓకే, రేంజ్ ఆల్సో మస్ట్ బి హై and it must be sensitive to desired signal and insensitive to unwanted signal. Means, right, this is another good point. So desired signal ke ఇది నేను మెజర్ చేయాలండి. అన్వాంటెడ్ సిగ్నల్స్ మెజర్ చేస్తే నాకు ఏమవుతుందంటే నాకు అవుట్పుట్ లో నాయిస్ యాడ్ అయిపోతుంది. సో అన్వాంటెడ్ సిగ్నల్స్ కి రెసిస్టివిటీ ఎక్కువ ఉండాలి, desired signals ki sensitivity ఎక్కువ ఉండాలి, right? And it must be preferably small in size so as to compatible with the total system which I am using. Okay, and now it should be able to work in corrosive environment. Okay, corrosive environment లో వర్క్ చేయగలగాలి అంటే the instrument must be non-corrosive. Okay, in any environments ఆ విధంగా ఉండాలి. And it must be able to withstand high pressures, shocks, vibrations, etc. Okay, and now the transducer must be free from errors and the transducer circuit should be able to have overall protection so that it can withstand overloads. Okay, ability to withstand load must be high, means ruggedness must be high. And also another point is cross sensitivity. Cross sensitivity must be high. Cross sensitivity must be high means cross sensitivity means for example, I want to measure temperature in a petrol well. Okay, let us take example of ONGC. ఓఎన్జీసీకి వెళ్తేనండి ఎలా ఉంటుందంటే ఓఎన్జీసీ బావులు తవ్వుతారు కదా, రిగ్స్ వేస్తారు టు గెట్ నేచురల్ గ్యాస్. ఓకే, అండ్ పెట్రోల్, నాఫ్తా, క్రూడ్ పెట్రోల్ ఇవి మనం భూమి నుంచి వెలికి తీస్తారనమాట. సో ఏం చేస్తారు అంటే 1 కిలోమీటర్ 1.5 కిలోమీటర్ లోపలికి రిగ్లు వేస్తారండి, ఆయిల్ రిగ్స్ వేస్తారు. సో ఐ హ్యావ్ టు మెజర్ టెంపరేచర్ దేర్. సో ఇట్ ఈస్ నాట్ పాసిబుల్ ఫర్ మీ టు లే ఏ కేబుల్ which is a far apart. ఎందుకంటే కంట్రోల్ రూమ్ ఒక 2-3 కిలోమీటర్స్ దూరంగా ఉంటుందండి కంట్రోల్ రూమ్. ఓకే, 2-3 కిలోమీటర్స్ ఈజ్ వెరీ స్మాల్ డిస్టెన్స్. ఓకే, ఒక 4 కిలోమీటర్స్ 5 కిలోమీటర్స్ కూడా మినిమం ఉంటుంది, డిస్టెన్స్ ఉంటుంది కంట్రోల్ రూమ్. ఓకే, అంటే నేను మెజర్ చేయాలనుకుంటున్న ఏరియా వచ్చేటప్పటికి 5 కిలోమీటర్స్ దూరంలో ఉంటుంది. ఇట్ ఈస్ నాట్ ఫీజిబుల్ ఫర్ మీ టు లే కేబుల్స్ ఆఫ్ అరౌండ్ 5-6 కిలోమీటర్స్ లాంగ్. 5-6 కిలోమీటర్స్ లాంగ్ నేను కేబుల్స్ వేయలేమండి. కాబట్టి ఏం చేస్తాము అంటే ఆ ఆయిల్ రిగ్స్ దగ్గర విల్ ప్లేస్ సూటబుల్ ట్రాన్స్డ్యూసర్ టు మెజర్ టెంపరేచర్. ఓకే, సో సూటబుల్ ట్రాన్స్డ్యూసర్ వేస్తామండి, కనెక్ట్ చేస్తాము, పెడతాము. అక్కడ పెట్టి ఏం చేస్తాము అంటే త్రూ అన్వైర్డ్ కమ్యూనికేషన్. ఓకే, కమ్యూనికేషన్ ఇస్ ఆఫ్ 2 types. ఓకే, వైర్ కమ్యూనికేషన్, వైర్లెస్ కమ్యూనికేషన్. రైట్, త్రూ వైర్లెస్ కమ్యూనికేషన్ మనం ఏం చేస్తాము అంటే కంట్రోల్ రూమ్లో ఉన్న రిసీవర్కి ట్రాన్స్మిట్ చేస్తాం డేటాను అనమాట. ఓకే, సో అప్పుడు ఏమవ్వాలి అంటే ట్రాన్స్మిటర్గా వర్క్ చేస్తున్న సెన్సార్కి సెన్సిటివిటీ ఎంతైతే ఉన్నదో రిసీవర్గా ఉపయోగిస్తున్న ఇన్స్ట్రుమెంట్కి కూడా సెన్సిటివిటీ అంతే ఉండాలి, లేకపోతే ఎర్రర్స్ వస్తాయి అనమాట. సో ఇట్ ఈస్ కాల్డ్ క్రాస్ సెన్సిటివిటీ. ఇట్ మస్ట్ బి హై. Okay, so these are the factors which we have to consider while selecting a proper transducer for a particular measurement, right? And now, what are the requirements? Requirements are also equal as factors to be considered, right? So small in size, lightweight undali, high sensitivity undali, low cost undali, ability to withstand environmental conditions, ability to withstand load, and linearity undali, and accuracy undali, and then repeatability must be there, reproducibility must be there. Okay, so all the static characteristics, essential static characteristics, all the essential static characteristics you can list out here, right? So these all for today's class, and in next class we will move on to this first classification, right? First classification, which is classification based upon principle of transduction. Okay, this is all for this class, right?